So if you watched my last video, you'll remember that we made the wing for our giant 10-foot A-10 Warthog that we're building out of foam board from the Dollar Tree. In this video, we'll be finishing up and giving the plane its maiden flight. So once I got everything cut out, I glued the fuselage together. Overall, it was pretty easy, since this plane is designed to be folded together. Despite my worries about the plans being scaled up, everything actually lined up really well. Since this thing is built in two sections, the front and the back, it made it a lot easier to work on in the limited space that we have. The nose section was pretty fun. It looks pretty complex, but once you start folding it really just comes together on its own. For the nacelles, we used 1/4 inch plywood and then wrapped the foam board around it. This, along with the canopy, was probably one of the more challenging parts of the build. The tail is actually kinda cool. I used some carbon fiber practice arrows I had laying around and cut them to length so I could fit them inside the vertical stabilizers. I also double layered the tail fins, partly to hide the arrows and partly to add more strength so the whole thing wouldn't flex. Then I used some more carbon fiber arrows inside the horizontal stabilizer, and also added a couple running from the verticals to the horizontal to keep everything from twisting around. I also added extra support to the elevator, since it's a pretty thin spot and is just asking to break in flight, which is the last thing we want. For the firewalls, control horns, and the gun, I 3D printed them out with my Creality K1 SC, which, if you're looking for a 3D printer, is a great budget high-speed option. Because this plane is going to be so big and heavy, we're going to need a lot of power. So we're going to use these huge 50, 65, 400 kV motors. They may not look massive at first glance, but compared to what we normally use on our other planes, these things are huge. For the servos, we're going to need something strong enough to move those big control surfaces in flight. So we're going to use these 55-gram Metal Gear servos I found on Amazon. And by the way, I'll be putting links to everything I use down in the description below. Originally, we were going to run 16x8 props, but when we ran a thrust test, it only gave us about 10 pounds of thrust each. So we decided to move up to 19x8 props, which should give us about 15 pounds of thrust per motor, giving us 30 pounds of thrust in all. For batteries, we are running 25 volts, so we're going to use a couple of these 6S5200 LiPos we picked up off Amazon. Though for some reason the price on these batteries seem to fluctuate a lot, so I will try to provide some links for some cheaper options down in the description below, because these have gotten a lot expensiver since when I bought them. Now let's move on to the nacelles. These were pretty simple, although I did add some 1/4 inch plywood inside to keep things stiffer, especially with those beefy motors, which are going to make a lot of torque. Now of course, if we're going to do all this work building it, it has to look good, so we're going to paint it before Maiden. I know this is the thing you're not supposed to do with RC airplanes, but I always seem to do it anyway. Before painting, we have to coat the whole thing in Minwax to keep the paper from soaking up the paint and lifting from the foam. Once the Minwax is dry, we can finally start painting. For this, we're going to use granite colored Rust-Oleum spray paint that you can get at the hardware store. It actually turned out pretty good. The only downside was the cold temps, which made the paint surface a little rough. Now comes the last part, decals. Decals can add so much to a plane. For this, we're going to use this decal paper that you can get off Amazon and print on a regular inkjet printer. Now the plane is done, we can finally maiden it. But for this, our regular field is going to be way too small, so we're going to head to a nearby farm field. Setup at the field went pretty well overall, but the cold temps we had a couple things go wrong, and one of them would turn out to be devastating. First, we were planning on mounting our batteries inside the fuselage using Velcro, but when it came time to stick it on, the adhesive wouldn't hold on because of the cold and damp. The other issue was that with the freezing temperatures, our cheap servos started locking up. We actually had to work them back and forth for a while just to thaw them out enough to move properly. Now comes the moment we have all been waiting for, the maiden flight. Launch was super easy, and at first it was flying great. But after about one full circuit, the plane started on a long, downward dive, which ended in disaster. But this isn't the end of the road. Make sure to subscribe to see whether we decide to tape and glue this thing back together, or repurpose these motors into something else. Thanks for watching, I'll see you in the next one.